Hello, I'm Matt Teal and welcome to the Military Tech Show. We'll be bringing you the latest in military and security technology, the hardware and kit that could change the future for armed forces across the globe. Coming up on the show, we've got exclusive access to the new long-range precision missile that could be the key to success for Britain's newest fighter jet. How mixed reality could mean the end of paper maps for the military. We give you the tech spec on one of the most advanced military jets, the Eurofighter Typhoon. And I'm in the driving seat at the go-to international event for emerging military simulation and training. Now, the European missile manufacturer MBDA has been asked by Britain's Ministry of Defence to develop a new state-of-the-art missile for the country's future F-35B Joint Strike Fighter. It's called the Spear 3 and will involve 4 years of critical design and development. Eventually, it's hoped the weapon's precision and punch will give pilots decisive operational advantage. In an exclusive for the Military Tech Show, we've been given a walkthrough of how this next-generation missile will work.
Hi, I'm Tom from MBDA. I'm going to talk to you about the Spear weapon system. Here I have a half-scale model of the Spear system as it would be integrated onto the Joint Strike Fighter. We have a launcher and 4 missiles, and this would fit inside the bay of Joint Strike Fighter alongside the Beyond Visual Range air-to-air missile Meteor. Key aspects that you see here: missiles are held upside down, the wings are on the base, the fins are folded, it's a very tight package. This is the launcher structure, and this is the component that you saw in half scale on top of the missiles. This is carbon fibre produced in the UK. It's very stiff so that when you eject a weapon or a store out of the Joint Strike Fighter bay, the reaction on that launcher is minimized, so it doesn't flex, it doesn't bend, and it doesn't mean that any of the other furniture or weapons in the bay are damaged. To eject the Spear 3 missile from the Joint Strike Fighter, we use a cold gas ejection release unit. This is precision engineering, again from the UK. It's designed to eject the Spear 3 store out of the Joint Strike Fighter bay at a high velocity to ensure that the bay doors are open for the minimum length of time, and the Joint Strike Fighter can then return to its low observable configuration. This is a model of the seeker that we are integrating onto the Spear 3. Very similar to the Brimstone seeker that we see today being used by the RAF in ops, but this is the next generation. So it takes the high precision that you get from Brimstone today, but will deliver that same precision in a within visual range engagement to something much longer, beyond visual range, beyond the horizon. Has a semi-active laser channel, so very similar to Brimstone in that the pilot sees the target, designates it with his laser pod, and then engages the target. It also has a radar aspect, which in this case images the target, so it uses more power and more processing to allow us to start creating a picture of the target area and ensuring that we can engage the target, not anything that looks like a target, and ensuring that we don't engage any of the collateral. This is a test asset from the airframe and propulsion demonstration trials that we undertook. In effect, what we did was wanted to demonstrate that we could develop a new missile, integrate it onto a platform, and then launch it, control it, and fly it for a considerable period of time. This was our spare and was also one of our test assets that we integrated directly onto Typhoon. No seeker, no warhead, because we weren't demonstrating those aspects of the system, but we were demonstrating the ability to launch a missile, control a missile, and fly a missile under power for a considerable long period of time. This missile was used for typhoon handling trials and also for the range workup trials to ensure that the range could hear the telemetry from the missile before we took its sister and flew it for the first time for real. This is a full-scale model of the operational missile. So now you can see there's a seeker where the blue band is where the warhead is kept. The significant differences between this and the model you see behind us primarily is that on that test asset, the fins are already open, but in the constraints of the Joint Strike Fighter Bay, the missile has to have everything folded up, and this includes the fins. So when the missile is ejected from the bay, the fins open, control the missile, roll the missile, the wings open, the turbojet then starts, and the missile conducts its mission. And that is the Spear 3 weapon system.
Well, the Spear 3 has been successfully test-fired by another jet flown by the Royal Air Force. It's an aircraft that can reach Mach 2 and climb to 55,000 feet and represents the peak of British, German, Italian and Spanish technology. So, what is the Eurofighter Typhoon? It's the buzz term that has all of Silicon Valley excited, and it could one day mean transformational change for troops on the ground. Essentially, you take a virtual reality headset, those boxy goggles holding a computer-generated screen in front of your eyes, and you apply it to real-life objects, say a table, and you get what developers call mixed reality. And for award-winning academics at the University of Birmingham, it could mean soldiers will never see the battlefield in quite the same way again.
As you can see here, I've got two gloves and I've got these special markers on. Each marker has got a ball on which reflects infrared light, and we are surrounded by 12 infrared cameras, so they can pick up the different points and triangulate a position for each of these objects. So when I put on the gloves, we can track them in the virtual world. And as you can see from the headset, it's got a camera on so I can see, as well as another marker, so my head is tracked, so we can link up the virtual and real environments. And when I finally put on the headset, I can now see the mixed reality table, which is being superimposed over this rather standard table. And the way the system works is it's very much like a map, and it enables you to interact with that in a quite intuitive way. So you can just sort of pinch to zoom with your hands to move in and out. You can also use your hand at the edge of the table, which rotates the map around. And you can also, of course, move in with your head itself, because everything's fully tracked. So as you step around the table, it follows you.
It's a fully immersive virtual reality. The user can even bring up documents and mark routes and zones on the virtual world.
We've got this puck-based marker. This enables us to mark out safe and dangerous zones. Simply twisting this would enable us to select the green zone, which may indicate a safe zone, and then we can literally just paint out big sections of the map which we now believe are safe. And we can also paint out sections that may be enemy territory. Ideally, this system is a sort of fully integrated system, and any kind of data source can be visualized and from any sort of location. So whether it be a drone or a troop on the ground, or satellite data. We can sort of integrate it all, and that data can be sound, videos, updated terrain data, could be social media data that's come in, and we can just bring it all into one location, and then it sort of give you that sort of full 360-degree space in which to show any data that's coming in.
One day, a system like this could be a fully portable command centre carried in a briefcase. Data from drones would instantly update the map in real time.
A research team from the University of Pittsburgh has demonstrated for the first time ever in humans the experience of touch sensation through a robotic prosthetic arm connected directly to the brain. Well, the hope is that one day it could help military amputees regain their sense of touch. The work is funded by DARPA, the Defence Advanced Research Projects Agency. The study's volunteer, Nathan, who became quadriplegic after a car accident, underwent surgery to have 2 microelectrode arrays the size of shirt buttons placed into his sensory cortex. That's the region of the brain responsible for identifying tactile sensations, such as pressure. They were then connected by wires to a robotic hand and arm fitted with tactile sensors in its fingers. As the researcher applied pressure to the robotic fingers, those physical sensations were converted into electrical signals that fed directly back into Nathan's brain. Well, through this brain-machine interface, electrical signals are delivered as precise stimulation, which his brain interprets as if his own fingers are being touched. And despite being blindfolded, Nathan identified with nearly 100% accuracy which fingers of the robotic hand were being felt.
Index, index, ring.
The gap between human and machine is closing. Well, that's it for part 1, but still to come, how Hollywood and the gaming industry are transforming military training, and why 300 years of research and development has led to a fiercely effective new drone. Hello again, welcome back to the Military Tech Show, where we spotlight the very latest in military technology. Now, across the military, defence budgets are often tight, which can limit the amount of real-world training on offer. But thanks to some groundbreaking advances in simulators, virtual reality and emulation, alternative teaching and practice environments can prove just as effective. Well, I went along to ITech, the key international forum for the very latest in military simulation and training, and saw how the virtual world prepares the military for life in the real world. Simulators, emulators, call them what you want, but they're getting closer and closer to the real thing. ITech had some of the latest on the market, and I asked the manufacturers what they can do for the military, including one that left me feeling distinctly green.
It's a robotic motion simulator platform. We place it on a 20-foot container, so it's a mobile platform that you have. It's an industrial robot. It's the system we have here is capable to carry up to 300 kg load. We have a cockpit integrated here with an HMD, so you're in the virtual world. You can turn your head, see all the motion around, and the robot does the flight motion of the system. We use washout filters to simulate motion that you do. For example, if you accelerate, the robot moves up front, and then we tilt the cockpit a little bit, so you actually feel that the acceleration goes on, but the robot moves back. So we can make 360 rotations, we can use the whole system as a centrifuge, turn endless.
How do we put a price tag on this? How much does this bit of kit cost?
Well, for you, we make a special price. No, it's actually like the platform we have here is about a little less than 500,000 euros, and the biggest and most expensive system we did so far was 2.5 million euros.
It's a lot of money, but simply putting a fast jet in the air for an hour costs tens of thousands of pounds, so even pricey simulators can save money. There were trainers for all kinds of roles, including joint terminal attack controllers, the men who call in airstrikes, and artillery.
Within this, I have full emulation of all the training devices that I would use in real life. So I have 2 immersive radios that are accurate to what a US JTAC would use, along with a VDL feed, which is a video downlink feed, giving me a view of what the aircraft is looking at that time. On this side, I have 2 radios as well that I would be using, along with a GPS receiver to get my position and to also generate target coordinates based off of this device. This device is another emulator. It emulates 2 laser rangefinders, both within the inventory for NATO JTACs. A laser target designator giving me the ability to self-laze munitions off of aircraft on the ground, and a mil reticle bino giving me the ability to adjust fire from the mortar based off of corrections from impacts.
What we have here is an appended mortar. It's a 60 mil mortar. It works like a real mortar. You can do your adjustments. You have your sight on it. So I can do my adjustments, right, left, up, down, going by the commands from the forward observer. It works with simulated rounds. They're smart rounds, so you have charges. Depending on how far you want the round to go, you can either add or take away charges. It also has fusing on it. This is a smoke round, so there's only 1 fuse or 2 fuses. So you can adjust that. You can drop this to mark a target. It is hooked up to air so that you get some recoil. This could be used to mark a target for the aircraft flying around. I drop it here. It shows up in the scene for the JFO or the JTAC, and the pilot on the pilot station can see it as well.
There are 2 distinct types of simulators here. There are ones that allow people to train to do things that they can do in real life if money and logistics and time were no object, but also the ones that allow people to train to do things they can't yet do in reality. And those are the ones that are helping to shape the future of military technology.
This is a simulation of the Queen Elizabeth class carrier, which isn't yet in service. And we've been able to use this simulation environment for several years now to refine things like the design of the carrier deck, the visual landing aids you can see, some of the systems on the aircraft, and some of the approach manoeuvres that you're seeing being played back here. And we've been able to use the simulation environment in an engineering context for several years now, before the aircraft and the ship were even built.
So military simulation, emulation and even formulation are all happening right now in the virtual world. A new kind of drone, based on one of nature's most deadly creatures, is set to revolutionise the way soldiers on the ground gather intelligence. Backed by the Defence Science and Technology Laboratory, a UK company called Animal Dynamics is developing the Skeeter drone. They say it will fly faster, further and for longer than soldiers' current miniature drones, because it's built on 300 million years of research and development.
So the reason we base this on dragonflies is we looked at what's out there in the real world, and dragonflies, they hunt and kill all the other insects. So they outperform all the other insects. They hunt them down in air-to-air combat. The thing with dragonflies is they've had 300 million years of R&D in the fiercest battlefield you can get, which is out in the real world, fighting air-to-air combat, where the males fight over territories where they might find females, and the females fight over territories where they can lay eggs. And a consequence of that is that as an aircraft design, as a flight design, they're fantastically over-engineered. And you can see that when you look at how good they are at catching their prey. It catches it 9 times out of 10. So we've been inspired by that to develop these flapping wing vehicles. And part of the reason for that is I've been working on insect flight at Oxford University for 20 odd years, and we cracked the insect flight problems about 10 years ago. And one of the main things we learned is that dragonflies actually are probably the pinnacle of insect flight designs. It's going to have performance that's similar to a dragonfly, and if you watch dragonflies flying, the ones we get in Britain can do maybe 45 miles an hour. They can accelerate for short periods, for a few seconds, quite a lot faster than a Formula One car. They can pull 5G acceleration for a short period. And there are other species around the world. There's one called the globe skimmer that lives either side of the Indian Ocean, and it migrates across the whole of the Indian Ocean. So they're capable of really long-range flights, long endurance and high performance, and that's why they're a good target for us to try and mimic. Compared to a conventional helicopter-like drone or quadcopter, flapping has a number of advantages. The most obvious one is compared to a helicopter. With a helicopter, you've got the blades spinning, lots of inertia and gyroscopic forces in those, which means it's slow to maneuver. But the other problem is that one of the blades is going forward. So as you're flying towards into the wind, say, one of the blades is going forwards, the other blade is going back, and that generates a roll moment, turning force. And inevitably, that's what limits the speed that they can cope with. And the speed is what limits the wind strength that they can fly in. Whereas with these, they're completely symmetric. The left side's doing the same as the right side. So there's no roll moment. It's fully stable, going straight level flight. But also you can control the thing at a rate that's the same as the wing beat frequency. So you've got really high bandwidth on control. So if you get turbulence and gusts in there, you can respond instantly and keep the platform doing what you want it to do, not doing what the wind is telling it to do. So timeline on these things. Well, 5 years ago, I don't think we would have been able to produce these. So what's driving development now is that, particularly through the mobile phone industry, the electronics, the cameras, and particularly the batteries have got much better. Smaller, lighter, more powerful. And that's what's allowed us to develop them now. So the big advantage this gives the soldiers is it gives them a small surveillance drone they can carry anywhere in the field and they can use in normal operating conditions. So it might be a bit windy, a bit dusty, it might even be a little bit of rain, and these things can still operate. Already people have started using these very small drones as a way of getting surveillance information in places that are difficult to reach with other vehicles. What this is going to do for the soldiers is make that something they can do every day. So we're producing them down to a cost where the soldiers can use them without worrying about having to go and find them later, and we're building them so that they can cope with any kind of conditions that you might encounter in normal operating situations. And it's carrying cameras that can work in daylight and low light conditions, so you can fly it around a corner, over a wall, into a compound and see what's there before you have to expose yourself to what's going on, which might not be something you want to see. It's nicer to see it with this than first hand.
And that is it from the Military Tech Show for now. We hope you've enjoyed the programme. Until next time, bye-bye.